Your Docker image is probably twice the size it needs to be, and I can prove it in next 30 minutes. Today we learn the one pattern that separates bloated amateur images from lean production images, and it comes down to how you write a single instruction, that is run, run. Welcome back to the kingdom. This is the image number 4 in Docker 100 images series, Zero to Architect. I am Himanshu Gupta. In images 1, 2, 3, we learned from copy, CMD, port mapping, and the run instruction. Today we go deeper into run. We learn how to install software the right way, and more importantly, why the wrong way cost you real disk space and real build time. Here's the plan. First, we switch from Alpine to Debian and learn apt-get package manager. Second, we build a bloated image the wrong way. Third, we rebuild it the right way. And we compare sizes, we compare layers, and by the end, you will have a toolkit image that fetches live data from an API. Let us get into it. So we are again in our Docker 0 to architect directory. Let's list. So image folder is already there. Let's go inside the images folder, and you will see all the 3 images which we have created in our previous 3 videos. Now let's create a 4th image folder, that is toolkit 004 mkdir -p 004 toolkit. Okay, let's go inside 004 toolkit. If you list the content, there is nothing inside it. Now, the quick context before moving forward. In image 3, we used Alpine Linux. Alpine uses apt-get package manager. Today, we switch to Ubuntu, which uses apt-get. Why? Because in the real world, most production Docker files you will encounter use Debian or Ubuntu as their base. You need to be comfortable with both. The package manager changes, but the principle are identical. Install what you need, remove what you don't need. So let's start with the wrong way first. That is the bloated Docker file we will create. Let me show you the most beginner, like what beginners do all the time, and honestly, what a lot of tutorials teach. We will create a file called a Dockerfile dot bloated. That is Dockerfile dot bloated. And the file looks like the content looks clean. There are like 3 separate run instructions we are putting in the file. That is apt-get update. Then the second instruction is apt-get install -y curl jq. And the third one is run rm-rf wall lib apt list. So as you see, each steps we have created on its own line. Easy to read, but here's the problem, and this is the critical to understand. Every single run statement or run instruction creates a new layer in your image. A layer is a snapshot of file system at that moment. So what happens? So layer 1, where apt-get update downloads the entire package index, megabytes of data now backed into that layer and that is forever. Then layer 2, apt-get install downloads and install curl and JQ plus all 3 dependencies. And the layer 3, rm-rf, removes the package list. But here's the trap. The file were already saved in layer 1. Deleting them in layer 3 does not actually remove them from layer 1. The final image still carries those bytes. The delete just mark them as gone in the top layer, but the data is still there underneath. It is like crossing out a line in a book. This ink is strong. This ink is still on the page. Let us build it and see what happens. So let's save it first. WQ uh, cat the content dockerfile dot blotted. You will see all the 4 instructions. Now let's build it with docker build -t uh, toolkit bloated. That's our image name with 0.1 and docker from dockerfile dot bloated. Hmm. Oh, it's docker build. My bad. Now, watch the output. You will see 3 separate steps here and one of each from run instruction. Each step is a layer. So when it created in 3 steps. So this is one of the layer 2 run, layer 3 again run, and layer 4 again run statement. Okay. So this is the bloated image we have created. Okay. And you will see it takes around 16 seconds. Now let's do it the right way. Okay. So let's create one more Docker file. Just name it as a Docker file. And now put the content differently. That is, let me walk you through what changed here. And we combined all 3 commands into a single run instruction using backslash for line continuation and double ampersand to chain commands. Like it will run one after the other. That's double ampersand. This means update, install, cleanup all happens in the same layer. 2 key details. First, the flag no install recommends. By default, apt-get install recommended packages that you probably do not need in a container. You want the bare minimum. This flag skips those extras and save the real space. That is this. No install recommends. Second, the cleanup rm-rf here. If you see this, rm-rf wall lib apt list star happens in the same run instruction and the same layer. So the package index files are created and deleted in the same layer. They never get backed into a final image. They are truly gone. Think of it this way. If you spill coffee, clean it up before anyone takes a photo, the photo is clean. But if someone takes a photo after the spill and another after the cleanup, you have the 2 photos, one still shows the mess. Local layers are photos. Keep your mess and clean up in the same photo. So let's build our second this clean image. Let's save this one and let's run docker build again. Docker build -t from image and build context. This is the toolkit bloated zero. Sorry, this toolkit will be the name of our image which we are creating, and the build context. Build context always take the Docker file. Earlier we changed the name. That's why we have to mention the name here, which Docker file we needed. We need there, but if we if we just use build context, that means it will take by default only Docker file. Let's create it. So you will see only one layer created. There is no another like third or fourth or fifth with run. Now the moment of truth. Why we do this with the two different images. So let's do Docker images and grab toolkit. You will see here. Look at those numbers. And compare them. The bloated image is noticeably larger than the lean one. So if you see 153 MB, then the lean one is 74.7 MB only. The difference is the package index metadata trapped in layer one of the bloated build. Now let us go deeper with Docker history command. Okay, so Docker history toolkit bloated dot 01. Let me copy it from here. Okay. So, and also count the number of layers here. If you see 1, 2, 3, 4, 5, 6, 7, 8, 9. Now do same with Docker history uh, toolkit 0.1. That is our simple. You will see 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here if you see there are separate three run layers here, 1, 2, and 3. But in our normal image, there is only one run layer. So all the work combined and the total is smaller because the cleanup actually worked. And this is the pattern. Memorize it. Apt-get update double ampersand apt-get install with no install recommends double ampersand rm hyphen rf. That is, let me get Dockerfile. So all this in one all in one run statement every time will save you a lot. So let's go to the next part. So you will see we already like our image is curl and jq, so let us actually use them. We will write a script that fetches a random fun fact from a public api and pretty prints it. So let's create a file, pwd. We are already inside toolkit. That's for 004 toolkit. So let's name our script as fetch fact dot sh. You can copy paste this command from GitHub, uh, and I'll explain it in few minutes. But it's a shell script, and we are fetching like we are using curl and you useless fact.jsp. Uh, and, from that particular URL, we are fetching some data. Let's save it first. Now we need to update our Docker file to include this script. So let's update the Docker file, which we already have. Okay. And so We again use the copy fetchfact.sh that is in our local uh, to this user local bin fetchfact.sh, and we also provided a permission here. So notice we kept a lean run pattern and added a copy for the script. Okay, the ch mode is a separate run, uh, and that is fine. It is a tiny layer, it's not a big one. The rule about combining commands applies specifically to the apt-get operation where package list creates bloat. Not every run needs to be combined with everything else. Use our judgment all the time. Now let's build it. So use docker bell -t, and let's name is toolkit 0.2 from build context. And the image has been created. Oh, now let's run the container out of this Docker image. So for that, Docker run -rm image name toolkit 0.2. So there it is. You see a random fact pulled from a live API pass with JQ displayed it cleanly. Every time you run it, you get a different fact. Run it a few times. Let's now the fact brought to you by the toolkit image. Uh, I think we are missing something here. Let's see. Let's run with this so we'll able to see where's the problem. So okay. So we error setting certificate files. We don't have CA certificates. Okay. So I think we might need to update our Docker file with CA certificates. So VI, or we can directly go to Visual Studio Code, and here it will be easy to update a Docker file. So we have added a CA certificates and our install command. Now let's build with another tag, Docker run rm toolkit 0.02. Since we have updated our Docker file, we have to rebuild it. Remember, we have to always rebuild. So Docker build -t and toolkit 0.3 and context for Docker file. It is building again. Now let's run Docker run 0.3. Oh, so you will see now we fetch from API the fact the US bought Alaska for 2 cents an acre from Russia, and source is djtech.net. Okay, let's run it again and see if we get a fun different fact. This time, the average human will shed 40 pounds of skin in a lifetime. That is, again, djtech.net. So here, if you see, we use -rm flag. Okay, it automatically removes the container after it exits. Keep things tidy. We will use this more going forward. Okay, so this is a very important like Docker run rm. Now let's go to lazydocker to inspect lazydocker. Okay. Now navigate to the images, find toolkit 0.0. So sorry, 0.3. Okay. And also the bloated one. Compare the layer counts here again. You will see directly and compare the sizes also. You can see each layer, what command created it and how much space it takes actually. And this visual make it obvious why combining run commands matters. Now you can just need to click and you can compare it one by one. Press Q to quit from lazydocker. Lazydocker is a great tool low in your system. You just run like brew install lazydocker if you are on Mac, and it works. Now, let me give you three rules for run with apt-get. Tattoo this in your brain. So rule number one, always combine apt-get update and apt-get install in the same run command. If you separate them, the update layer gets cached. 6 months later, Docker reuses the stale cache and your install fails because the package index is outdated and you spend an hour debugging it. Rule number two, always use no install recommend command. You do not need main pages and suggested utilities in a container. Every megabyte counts when you are pulling images across a network 1,000 times a day. And rule number three, always clean up app list in the same run. That is rm-rf wall lib app list star command, which we used earlier. Same layer, same photo, no leftover mess. These three rules apply to any Debian or Ubuntu based images. For Alpine, the equivalent is apk add no cache, and Alpine does the cleanup automatically with that flag. But the principle, keep your layers lean, is universal. Now, interview question. Is senior engineer reviews your Docker file and see three separate run lines for apt-get update, apt-get install, and rm-rf. And they ask, why should you combine run command in a Docker file? Here's the answer that gets you hired. Each run instruction creates a separate layer in the image. Docker layers are additive. Data written in one layer cannot be truly removed by later layer. Deleting file only marks them as absent in the new layer, but the bytes remains in the earlier layer. By combining apt-get update, install, cleanup into a single run command, all temporary files are created and removed within the same layer. So they never persist in final image. This reduces image size, speeds up pulls and deploys, and saves storage cost at scale. That answer show you understand the layer file system, you understand the practical impact, and you know the production pattern. This is senior level thinking. Let us recap on your on your fingers. First, apt-get update and apt-get install belong in the same run always. Second, use no install recommends to keep it lean. Third, clean up app list in the same layer with rm-rf. Four, use Docker history to verify your layers. Five, the coffee photo analogy. Mess and clean up in the same snapshot or the mess lives forever. Now the homework part. Take our toolkit Docker file, add a third tool, maybe wget, maybe Python 3 minimal, maybe whatever you want. Build it, then run Docker history, count the layers, post your layer count in the command. Next time, image number 5, we learn copy and work directory. Where does your code actually lives inside the container, and more importantly, how does the order of your copy instructions make or break your build speed? This is next. If this helped, subscribe and join the kingdom. We are finally 100 images. Uh, Fourth image is complete, one concept at a time, and we are just getting started. And remember, don't forget, don't be the same, be better always.